Hello. Today we are going to discuss about the photoelectric effect and its experimental verification. So photoelectric effect means photo means photons, electric means current. So because of photons we are getting current. How it is possible? It is like this. Take a metal surface. When photons falls on the metal surface, then electrons are released. This phenomenon is called photoelectric effect, and these electrons are called photoelectrons, and with the photoelectrons you can get photocurrent. But how is possible? Like Einstein explained how photoelectric effect is the photocurrent. When the photon falls on the metal surface, that energy absorbed by electrons and they will break the metallic bond and they will catch the kinetic energy, and with that they will come out and they will move in one direction, gives current to us. Now, to know what the factors affecting the photocurrent, we have to do an experiment. Of course, scientists have done the experiments, and based on the experiments, they found that some factors are influencing the photocurrent, and those factors are potential difference between photometals. First factor, and second factor is intensity of radiation. Third factor, frequency of radiation. And fourth one, photometals used. So these are the four factors influencing the photocurrent. So they have an experiment. Okay, I am going to show the electric circuit, which will you can understand how they have done the experiment. The circuit is like this. They have taken a quartz bulb where two metals are placed. One is acting like negative plate cathode, one is acting like positive plate anode. This negative plate connected to negative terminal of the battery, and positive plate is connected to positive terminal of the battery through ammeter. Of course, in between you have a rheostat to vary the current, like this. Okay. So this is how the electric circuit is constructed. Now what happens with this battery? Now when the light rays fall on the negative plate, as the cathode plate and negative plate, it releases electrons, and these electrons pass towards positive plate because attracted by the positive plate, and electrons flow in the circuit so that current is produced. And this current is called photocurrent. And this photocurrent can be varied by changing the voltage of the battery. Now, by doing this experiment, they have found these are the factors influencing the photocurrent. Now we will see how these factors affect the photocurrent based on graphs. So the first one, potential difference between photometals. Potential difference between photometals. See, this is the graph we have drawn by taking the values. We have drawn the graph between potential, the battery, and photocurrent. So what you understand that the graph comes like this. Right. What it says means from the origin, when you increase the positive potential, photocurrent also increases. At one point, the photocurrent becomes maximum. This is the maximum. And after that, even though you increase the potential, the photocurrent doesn't increase. It comes to the saturation point. That is the maximum value. So that's why this region is called saturation region. Now, from origin if you move backwards, means when you increase the negative voltage, photocurrent decreases. At one negative voltage, the photocurrent becomes zero. This negative voltage is called stopping potential, or of course it is also called cutoff voltage. So stopping potential means it is is the potential where the photocurrent stops. So this is what you understand. So what is saying that when the positive voltage increases, photocurrent increases to maximum, and after that it remains constant. When negative voltage increases, photocurrent decreases and becomes zero at V0, which is called stopping potential. Now we move to the second factor, that is intensity of radiation. Intensity of radiation, now what it says. This is also what they have done. After doing the experiment, they have taken the values of potential and photocurrent like this. Now they have tested the photocurrent for different intensities of the radiation. The intensities goes on increasing. Like I3 is greater than I2 is greater than I1. So intensity from I1 to I2 increases, I2 to I3 increases. So what they observed that, of course, at each intensity it follows the same nature, like this. But as far as increasing the intensities, all are coming and concentrating at one point, which is called negative potential, which is also called stopping potential. It says that stopping potential independent. Stopping potential is independent of intensity. This is the main information you can find using this graph. Now, go to the third one, third factor, frequency of radiation. Here, they have taken different values for the frequency and stopping potential. Now, this is the graph they have got. So what it says that when the frequency increases, stopping potential also increases. That means stopping potential and frequency are directly proportional. When frequency decreases, stopping potential also decreases. But at a frequency nu naught, the stopping potential becomes zero. It says that at nu naught there is no potential. So nu naught is called threshold frequency. Threshold frequency means starting frequency. It is the minimum frequency required for photoelectric effect. So all the radiations whose frequency is nu should be greater than nu naught, then only photoelectric effect occurs. If not, photoelectric effect does not occur. So all radiation frequency should be greater than nu naught. Of course, from this we get another point like lambda naught, which is called threshold wavelength. Here the condition is all the radiation's wavelength should be less than lambda naught. As you know, the frequency and wavelength both are inversely proportional. As the frequency is greater than nu naught, wavelength should be less than lambda naught. This is what information you find from frequency of radiation. Now the last one, last factor, photometals. So the same graph between frequency and stopping potential they have taken for different metals. For different metals. This is metal 1. This is metal 2. What they observed that each and every metal follows the same nature. For every metal, V0 is directly proportional to mu. And the difference is that each metal has different threshold frequencies. So threshold frequency is different for different